is now starting. All attendees are in listen-only mode.
Hello, everyone. Glad you could join us today. My name is Don LaCourse, a senior application engineer for MecSoft Corporation, and I'm also joined today by Joe Anand. Joe is MecSoft's product manager. And as you can see on the screen, our topic today is very well anticipated what's new in version 2022 of both RhinoCAM and VisualCAD CAM. And Joe, okay. And just a few housekeeping tips. If many of you have joined our webinars before, you know that we leave a chat window open for you to ask questions. And those questions will be monitored here in the background, and we will have a question and answer period near the end of the webinar. And then also a recording of this webinar is being made right now, and we will process that and send you a link that so you can download and watch it online at your convenience. Next slide, Joe. So our agenda today is all what's new in version 2022. We've got a lot of exciting things going on in this version, and I think you're going to like them. We're going to start off by reviewing the VisualCAD enhancements. And VisualCAD, as you know, is the base CAD system for our VisualCAD CAM machining platform. Also, we're going to be going over a lot of usability enhancements throughout the product, both RhinoCAM and VisualCAD CAM. You're going to really enjoy the tooling changes that we've done. That's an exciting part that I like a lot. Also, they were going to show you some enhancements in hole making, milling, and turning. A lot of nice enhancements in each one of those modules. Also, we've got knowledge base enhancements, which will, if those of you who use knowledge bases, you're going to enjoy these enhancements we're going to talk about, and which will really make your work a lot easier. Also, we have some post-processor changes that you're going to like. A number of them you're going to really like. And then also changes to our licensing models. So let's get right into it. We're not going to spend a lot of time on slides. We're going to go right into the demonstration. Joe, you want to take over?
Yeah, thanks, Don. Hello, everyone, and welcome to our open webinar on our 2022 product. Without any further delay, let me get started. We'll start with VisualCAD. Not a lot of enhancements, but I would like to touch upon a few that are important for VisualCAD users. One of the things that we have added is display of line thicknesses. Actually, it's not just display, it's actually a property. A line thickness property. So I'll show you what I mean by that. So I'll create a simple rectangle. This is VisualCAD, our standalone CAD product. And typically this is line weight, it's using line weight 1. So if in any reason in my model that I want a certain curve or wireframe geometry to stand out in a different line thickness, I can set that up now. Right mouse click, go to properties. It'll bring up the properties dialog. And you can see one of the things that we've added is this layer thickness. So it's currently using the layer thickness, and I can set it to false. And I want to specify, override the layer thickness. And I'm going to set it up to, let's say, 5. And as you can see, that increases the thickness of the display. It's not just a display, it's actually a property of the object itself. So when you save and load the file, you will actually see it. So this is one of the changes we've made. A couple of other changes. There's modeling aids. We've added C-plane to a planar face. Planar curve. In the last release, a lot of you had requested aligning a C-plane to a planar face, and we've added that now. We've also added alignment of C-planes to planar curves. And then another major change is obviously something that you can probably see already is the 4K monitor support. And I'm actually running on a 4K monitor here, and I've had actually set up the custom scaling to 200%. And as you can see, it looks pretty nice. The display itself, all the icons are scaled properly, and you really don't see any difference between standard scaling or standard monitors and 4K monitors. So those are the big changes in VisualCAD. And most of my CAM demonstration, I'm going to be showing it in RhinoCAM, but all of that applied to VisualCAM as well. So let me switch over to RhinoCAM. So I got RhinoCAM loaded here. So let me first start with the usability changes that we have done. We've done quite a bit of this based on, all of this is based on your input and how people are either struggling with some of the items in our usability scheme. And of course, some of the things that we have also added based on a lot of support requests and things of that sort. So the first important thing that you probably will not notice is when we typically for older customers using older versions, when you load a part, a dialog used to come up and ask you whether you wanted to load the settings from the previous from the registry or from the file itself, and that was quite confusing to a lot of users. We've actually eliminated that, and by default, we're loading all settings from the file. So all settings are now saved with the part file, and when you load a file, your settings will be loaded from the file. When I say settings, I'm talking about these preference settings. All these preference settings now are file specific. We have some defaults that come with the system. So when you first load the system, you're going to get some defaults, but you can modify these and save it in the part file, and they will be saved in the part file. So for perpetuity. The other nice thing on the same vein, the other thing that we have done is post processors. So before, when we selected a post processor, we would actually load it from a disk. And then every time you load a file, we would go to the disk on the same location that you specify and reload that post processor. And we have changed that, the way that works now in 2022. So this workflow is once you come into the product, you load a post processor just like before. So this is a file that let's just say you're just starting out with this file. You're loading a post processor. And then when you save this file, this post processor is actually saved with the file. So when you come back in tomorrow or a year from now and you load that file, that post processor will be available for you. So you don't have to worry about different versions of the post on your disk or anything of that sort. And the other thing that we have done is we have split up the post processor dialog into two dialogs. One is the selection part goes here, and then we've also added the preference dialog here. So we're setting up preferences on how we want the outputs, the posted file naming conventions, and all of that can be set up here. So that's another important change as well. This should eliminate a lot of confusion from customers, and we definitely hope that is the case, because we found that's one of the biggest support issues that we run into. And then finally, but last but not least, but actually this is the biggest change under the hood, we have created, let me load this file with something that's got a toolpath. We have integrated the G-code editor. I'm not sure if many of you are familiar with the G-code standalone editor program that we supply with our product. That's available only for AMS customers. But now we integrated a piece of that G-code editor, or it's a viewer. It's really a viewing product right now. That's part of the system here. So as you can see, this is my MOPS, familiar MOPS folder. And under these, you have the tooling. These are all older ones. People are using our older product, are familiar with these. But we already also added a G-code icon here. So what this does is, once I noticed that when I loaded this part, the post was set up to be HOS, and it loaded it automatically. So I didn't have to specify. It is not loading the one from the disk. So this was actually loaded here. So let's say I regenerate this, and it's going to actually create the G-code, and I can double click on it and brings up the G-code viewer. This is actually the G-code that was post-processed. The post-processing is done automatically now when you regenerate the toolpath. and you can view the post-process output to make sure everything's okay. You can actually edit some of this stuff. So for instance, in this case, if I don't like the G20 there, I can remove it from here. I'll put the G20 all the way up there. Basically, G20 says it's running in inches mode. And once I do the edits, I can go back to my milling program. And as you can see, there's a star associated with the G-code icon, which basically tells you that the G-code has been manually edited after the regeneration has been done. Now, if you regenerate the toolpath, that star will go away, but what's happening is you're reposting, or the toolpath is regenerated and the post-processing is done again, and it's instantiated. So you're going to, all the changes, manual changes you've done are going to be lost. So you got to be aware of that. If you want to save something, you can actually suppress the mop if you want. And so it's not, if you've made some changes, you can save that change. And notice that the G20 change that I made is gone, and the G20 is back here at the T1 line, or the tool line. So that's an important change, and the reason it's important is now you have the entire machining environment, if you will, maybe not the entire machining environment, at least all the pieces in the product itself. You got the post file, or in the file. You got the post saved with the file. You got the G-code saved with the file, so it's completely contained in the part file. And we consider this as a step forward to finally bringing all of the different pieces in your machining environment into this virtual environment here. So this is just the first step, and you'll see as we move to new releases, you'll see other integrations like simulation of the G-code and potentially simulation of the machine tool as well using the G-code. So those are things that are in the works for next the subsequent releases of the product. Okay, let's talk about some UI changes quickly. I'm going to load a file to illustrate that. The big change is with relation to dirty mops. For those of you who are not familiar with dirty mops, what we call dirty mops is basically operation. Let's say you've created an operation, and then you've gone in and made some changes to the parameters or the tooling. For instance, in this particular case, I'm going to just change the shoulder length, and I'm going to save the edit to the tool. And I'm going to save my operation. I'm not regenerating operation. So now what it says is I see a star next to the mill or the cutter that I just edited. So basically it tells me that we call this the dirty mop, just in our local parlance. It's the reason we call that is because it needs regeneration. So this flag with the star basically tells me that this operation, one of the objects that are being used in the operation has been edited, and you need to regenerate this operation to get to avail of the edits that you've done in some of the objects below. So that's what I mean by dirty operations. So the operations that use that tool, they're all flagged as dirty. And so now we have a right mouse click option to delete dirty mops. I think some of you users use this quite a bit to do what if scenarios. So you're working with different tools, or you're trying out different tools, and sometimes you have these operations that you don't want to use hanging around, so you want to delete all these operations. So we've added that delete dirty mops. So basically it removes all the dirty mops from the operations tree. The other thing we've done, again, based on your input, is for suppressing operations. Now, suppressed operations, we got a lot of input from you saying, I want the suppressed operations not to be posted, but I want to be able to display it, and a lot of these different requests. So what we've done is we've actually changed that, customized it to customizing the suppressed mops behavior. Now you can assign custom properties to these suppressed mops. You can say, I don't want to simulate it, but I want to post it. In that case, I would uncheck this, and all suppressed mops will be posted, but they won't be simulated there in the mops. So these are the different properties that you can assign to suppressed mops. This is quite powerful as well for a lot of you who are using suppressed maps, again, in what if scenarios, doing a different types of machining, trying out different types of machining. So those are some of the important ones from the UI. Okay, so let's go on to the next topic, which is probably the biggest, most exciting change in terms of the architecture of the product. So, which is tool holders. We've added tool holders to the system, to the milling system. So I'm going to take a simple part for demonstration for these holders. I got facing pocketing. Let me simulate this operation. As you can see, I'll turn on the holder display as it's simulating. That's our standard holder. If people are familiar with the older product, they'll know that that's our standard holder that we are able to define in our product. Really nothing fancy. And a lot of you have requested us to be able to generate new holders. So what we have done is we've added holder support. So I'll show you how that works. So when you load an existing file, you're going to get this standard holder that you've saved will come in. As you can see, the UI is changed. We have removed the holder specification from the tool part of it, and we've actually added a new holder dialog here. So you can actually go in and create the holder, or modify the holder. I can say edit active. I can put a taper. Let's say I put a 15-degree taper, and then let's say edit the active. That's my active. I'm going to add a new segment, and let me make that 0, and then make it a diameter. Let me make it length 0.25, maybe 3. I'm going to add that as a segment. Again, I can remove that segment. So I got that, and then I can add a new segment. I'll make it something smaller. Actually, I will make, okay. I'm going to make that a little bit bigger so it looks realistic. Okay, so I've done that, and say where it's the holder. Cancel. So there's my holder. All right, now. So that's the holder that I created, and now it's being displayed, and I can use it. Say where is this tool? Generate. And the holder now is used in the operation. Regenerated it, and I'm going to simulate it. As you can see, the holder is now being used. And this holder is now part of the tool, and it's used in simulation and gout checking, as well as collision checking with different objects in your environment. So that's a big change. A lot of you requested that, and so that's what you have here. So if you have any questions on this, please go ahead and type it in the chat window, and Don is going to be monitoring that. So Don, if there's any questions on this, let me know. If you stop me, and I'll be able to demonstrate that.
Okay, we'll do.
Okay, yeah. All right, let's move on now to another exciting change. We've added a new operation type called saw machining in 2.5 axis. So this is for a lot of woodworkers. This is a pretty useful function. The other important thing is we've added this. You could have done saw machining using either profiling and using multiple setups previously. Some of your more sophisticated users have figured out how to do that. But we have added that function in the 2.5 axis standard configuration, which means you don't need to have multiple setups now for doing standard sawing. or two-axis sawing. So let me show you how that works. I'm going to bring up a part. Okay, that's a simple part that I want to saw the outlines off. So let me show you this saw tool definition. It's very similar to a shell mill definition. And it's integrated. It's a saw. So basically it's a rotary tool, if you will. And it's very similar to the shell mill, like I said. So this is something I've defined. Can regenerate it. So, all right, let me simulate it. Makes more sense. See, the rotation axis is being done, or the rotation of the tool is being done. There are some issues here, as you might probably notice. We're still working on this. It's still not quite ready for prime time, but I just wanted to show you. This is going to be part of the product when we do release a product in a couple of weeks here. So let me show you the toolpath itself. So this is our toolpath viewer. So as it comes in here, you see a rotate axis, which is basically it's rotating the tool. You can see a rotate axis. We are just rotating the tool at that point, so it orients itself parallel to that line, and then it machines that, and then it goes up. It does multiple Z. It's coming down and machining into multiple Z's. You can do it in one pass too if you want it, which typically, if it's soft material, you can do that. Then it does a transfer, and then it goes to the other one, and then it does another rotate axis, and then it comes around and machines that. So we automatically determine the angles that we want to rotate the cutter by. And also, as you can notice, we do not do a rip cut. Basically, we do not extend the cuts all the way out. As you can see, it determines what's the correct distance to step back from the edge of the cut. So it'll only cut what's needed to be cut because the saw is pretty big. So as you can see that. So, all right, that's our saw machining. And obviously the post processor needs to be set up to handle the rotate axis correctly. Which if you need help on that, we'll be happy to help you with that. So another enhancement a lot of people have asked for is this our start point control and facing operate 2.5 axis facing. Okay, I have a very simple part to display this to illustrate this. Okay, so what we have here, actually, I've already created a facing operation with the starting point, so I'm going to remove that. So if you had in the 2021 version, if you did a facing operation with this rectangle, and then this is my avoid region, and this could be a clamp or something like that I wanted to avoid, the cutter is going to engage in here. Standard engagement based on, this is determined based on how you created the curves. So the curve start point was here, so it picks up the internal logic, picks it up here. So the cutter engages in here. Obviously, if this is a fixture and you don't want the cutter engaging right in there, so, and you wanted to engage in a different place, that's why we given you this option to specify a start point. So you can go to start points and select start point. I'm going to do this. I've already created a point there, so I want to start close to that point. Let's do a generate, so it's going to start here. Cutter is going to start here. So that's you can define these start points for facing. You were in profiling and pocketing, you were able to do that in previous releases, but now we've added that in facing as well. Okay, let's move on to 3-axis. Any questions? There's a few other changes. I'm not going to jump into these are the major changes. If we have some time, I can step you through the What's New document. We also have a link on What's New document on our website. We'll make that available to all of you as well. So you're quite informed about what are the other things that went in. Let's jump into 3-axis. As far as 3-axis is concerned, we've done a lot of changes in adaptive roughing, which is basically our high-speed machining option. And this is a separately, you have to buy this as a separate license. It doesn't come bundled with standard. It's a separate module. In previous versions, the adaptive roughing only looked at the stock model to figure out where to cut. But now we've added the containment geometry. So we've added the ability to contain the cutter using part regions as well as part surfaces. I'll talk about that in a bit. In this particular case, I'm using the rectangular part here. Let me generate that real quickly. It shouldn't take too long, I hope. Okay, there you go. So I did a part. So it did a facing operation, so it knows it's coming from the outside. It did a nice face, as you can see. Let's step it by levels. So there's my first level. And this is my second level. And we've also added surface extent conditions as well. So I'll show you that in another model. So if you, sorry about that. So if you have an option, or if you have a surface model like this, and you have a pocket and then you want to machine only certain surfaces, what I've done in this particular case is I've selected only all the part surfaces that are displayed in green here. As you can see, everything inside the pocket I've selected. As you can see, everything is being displayed. These are the surfaces I want to machine, and I want to avoid the other surfaces, or I basically ignore it, not avoid it, ignore the other surfaces. But I also don't want to gouge the other parts. So what I'm going to do is we have these options where you can set the surface extent conditions. So I've set it to 2, which means the cutter is going to stop as soon as it touches that edge of that surface in 2D. That we're talking about 2D. So if I go up there to the top view, so as soon as the cutter touches, typically in a control geometry where you're using curves, it would be an on condition, which means the center line of the tool will be here. But in this particular case, I can specify a 2 condition, which means it'll stop right there. Let me regenerate it. And as you can see, the cutter toolpath stops right here, which means the cutter is tangent to that point. So that's an important function that we have added. This can come in handy when you're machining high-speed pockets. You want to machine pockets in high-speed manner. Well, let me run a simulation real quickly. As you can see, they're stopping at the outer boundary. Okay. Got any questions there, Don?
We got a few. One regarding the tool holders. A user had a question whether they could import holders. I'll let you go ahead and answer that, Joe.
No, not at this point. We can't import it, but you can import it as a model and then measure the parameters of that and then input that. So basically, the way you create it, as you saw in the holder definition, was segments. You're creating either cylindrical or conical segments. Those are the things that you can do now. Yeah, as I can see, similar to user-defined tools. At some point, we'll be able to, bring in a curve, maybe a surface of revolution, and then use that as a holder, but not in this release. In this release, you can only do, cylindrical or conical segments. Okay, I hope that answers that question.
We got a couple more, but we'll go ahead and recap. We can do all these at the end.
Okay. All right. Yeah, we got quite a few things to cover. So, so the next thing is step tooling. This is also this has been in the system, but we haven't really advertised this because there were some issues with the algorithms handling, especially in vertical surfaces. You would see some shakiness in the toolpath. We have reworked the algorithms completely for step tooling. And then this is the 2022 version where you can see it's been a lot more robust, and it's been, regularized quite a bit. So I'll show you what I mean by step tooling. I'll go in the definition of the tooling. So the step tooling is used when you have long, slender tools and you want to strengthen the shoulders with something that's thicker. So here you have this, the flute length, flute diameter is, shank diameter is only 4 millimeters, I believe, yes. And then the shoulder diameter, shoulder length is this much, flute length, tool diameter itself is 1.5. I'm sorry, shank diameter is this much. What happened to the shoulder? I think, yeah, that's the shank diameter. I'm sorry, the shank diameter is basically the 4, which is the thicker one, and then the tool diameter is 1.5, which is this part. The cutting part is that. So as you can see, the display. So this can you can use this in situations where you long, slender tools. That's your shoulder for additional strength. Let me do that. I'll get a better display of that. Into a preview tool. That's the tool holder. And this is the stepped tooling. So this is now completely in all 3-axis operations, you can use step tooling. That's a big change as well. It's an internal change. Mostly it's an internal change, nothing in the UI or anything like that. So, okay, moving on to 4-axis changes. We have reworked our R-level roughing and R-level finishing algorithms. There were quite a bit of problems with those before. So we have reworked that completely. And for those of you who are not familiar with the R-level roughing methods, you can think of it as horizontal roughing in 4-axis. So basically, we are roughing in layers, if you will. So that's basically, you can see it's kind of like onion layers. You are roughing it in multiple layers. And this can be very useful for stability reasons of your machine tool. So instead of running the tool up and down for roughing, this locks the rotation axes or rotation angle to a certain angle and does all the machining. So you can see the toolpath. Let me run the simulation. Let me actually run show you the different levels. So is it going cutting there? So that's one onion level, if you will. And then you go down on this side, you're cutting on the outside. You can use containment to remove those if you're not interested in cutting the other side. So as you can see, this is stepping down in levels, very similar to the horizontal roughing in 3-axis. This is, you can think of it the same way. So it's cutting down, and then you're roughing. Now, once the roughing is done, you can come in with standard, parallel finishing methods to finish that off. So it's a very useful tool to have, or a function to have when you have parts like this. And we've also added, fixed up the R-level finishing methods as well. And they can also be useful to machine a certain class of parts where you have features like this sticking out. So that's something that's sticking out of your cylinder, for instance. And the best way to machine this would not to go up and down, but go around like this. And you can again think of this R-level finishing as horizontal finishing in 4-axis. So that's another nice method that you can employ in your arsenal to machine different parts. So those are the changes in 4-axis. As far as 5-axis, we have added the output of Yaw, Pitch, and Roll for machine tools. Before, we used to be able to handle all the machine angles, but some new machines require the Yaw, Pitch, and Roll. And we have in the post-processing, and we have added the internal kinematics for that, the internal inverse kinematics to output Yaw, Pitch, and Roll angles for 5-axis. Really can't show that, nothing to demonstrate there. And then also we have done a lot of performance and stability improvements, especially in the tool axis stability. In some cases, we saw some shakiness with the tool axis, and we've worked on that to make that a little bit more robust as well. So those are the changes in 5-axis. Okay, let's move on to another change that we did, which also can be used in index machining or index 3+2 machining. This is called instancing. Some of you might be familiar with this. Let's say we had a part here, and I have a setup. As you can see, the orientation of the setup. I'm actually want to machine this face. Let's say I want to machine a part like this, but I had multiple parts. So I did a horizontal roughing on that face. I did a pocketing, maybe drilling, and then a profiling, hole profiling, and then hole profiling. Let's say I had two parts like this, and I wanted to machine this face twice. Before, I would use an XY instance. So the way you would do it is you would use an XY instance. Let's say copy, number of copies in Y. I'm going to give it 6. So I'll generate that. Let me move that XY instance up here and move all of these into the XY instance so you see what I'm doing. So if you look at it, there's all of the operations instanced along the Y-axis of the setup coordinate system. This is the way it was in 2021. This is the only way you could do it in 2021. But obviously, it's not very useful because the instancing is being done along the setup axis rather than the world coordinate system. So we've added an option in here to go to the world coordinate, parallel to world coordinate system. If I regenerate that, you can see it's actually moving it along the y-axis of the world coordinate system. So this allows us to be able to machine multi-sided parts, multiple instances of multi-sided parts using an instancing. This works both in XY and in polar instancing as well, so it's quite useful. And again, you can tackle a whole host of parts using these methods. So, okay, any questions there, Don? We're still doing okay?
Yep, we're okay.
All right, okay, let's talk about hole making. Another important change went into hole making, which is a selection of cylinders. There we go. There's situations in hole making where we don't have geometry to actually, we have the hole itself modeled, especially if you have a model that's coming in from a parametric system, but we don't have any associated geometry to pick. When I say geometry or wireframe geometry to pick to machine the hole. So for instance, if I got a model like this, in 2021, you have to actually go in and create the edge curves. You'll have to project it onto the C-plane so it's planar, and then you'll be able to select those for drilling. But now what we can do, we can go in to hole making. Oh, I'm going to do 4-axis. I don't want to do 4-axis. I'm going to do drilling. And we've added this new option called select cylindrical surfaces. So I can go in and select all those cylinders. Notice these cylinders are actually truncated cylinders. They've been actually intersected and by this surface, so they don't have they actually have the curved edges on top. So once I do this, the system automatically figures out the cross section of the cylinder and puts that curve right up there at the topmost part of that hole. And then obviously then I can select my tool, which I've already done, and generate. So now we got that drilling operation. This is very useful when you have situations like this where we don't have curves, and also in 4-axis, especially in 4-axis where you might have holes on a cylindrical part of a portion of a surface, and it's not easy to just create geometry there to use 4-axis hole making operations. So this is an important change. Another important thing that we have done is we have come up with a scheme in 2022 to actually handle drill banks. So if you have multiple drills on a drill head with X and Y array of tools, we have a scheme. We now have a scheme where we can actually create toolpaths using these drill heads. It's a combination of using the tool numbers and the post processors. So we have special posts for drill heads. So if anybody is interested in that, we can help you out. Contact us and we can help you out in 2022 with drill banks. Okay, let's talk about knowledge bases now. Just moving on. I'm hurrying a little bit, so excuse me for that because we got a lot of things to cover. So those of you who are familiar with knowledge bases might like this enhancement. What we have done is we've added additional rules, geometry selection rules for knowledge bases. I'll illustrate how that works very quickly. Let me take this. Okay, I have an example here. Let's say this is a part, maybe a cabinet. You're machining multiple cabinets. And you're creating these cabinets using some other program, I don't know, Cabinet Vision or Grasshopper or any other types of programs that are able to spit out these cabinet designs, and you want to machine these. And you can set these up in different, depending on your creativity or depending on your needs, you can set up the geometry that is being created, that is being output in different colors and different layers and things of that sort. In this case, what I've, just for illustration purposes, I have a rectangle. Let's consider that as an outer periphery of my cabinet, if you will. Then I have two pockets in the cabinet. One is a red, defined by this red rectangle, and then one is defined by this circle. So now if I have all these multiple ones, I can set up a knowledge base and use the automation, the power of the knowledge bases to create machining operations. So let me show you how that works. So I load that knowledge base we've already set up. I'm calling it the widget with the rules. I'll talk about the rules in a minute, but I just want to show you how that works. So I've loaded that operation. Now, I'm sorry, the knowledge base. The knowledge base, when it loaded, it automatically picked up control geometry for machining. So it said, okay, this pocketing, I'm going to machine only those rectangles in red. This whole pocketing, I'm only going to machine the curves, circles. And then the profiling, I'm only going to machine the outside periphery. So I can set up these so this can be done automatically, and I can do a regenerate. And it's this, as you can see, is a lot faster than actually going in and selecting individual curves, and it can be a nightmare if you have a lot of these. And so this is a big productivity improvement or enhancement. So let me talk about what I mean by the rules, how this was set up. So let me bring up the knowledge browser. So I'm going to go to the knowledge base browser here. I'm going to load that knowledge base that I just used for machining this. So these, as you can see, these are the three operations that are set up in the knowledge base. So in the knowledge base, we have something called selection rules. This was already there in 2021. We've enhanced this in 2022. We've added this logic. So you can use the logic of and or. When you say and, in this particular rule, the rule that I'm setting up is I want to machine all rectangles, but also only those rectangles that are red in color. So rectangles and red color rectangles. So that's this property that I'm setting up. And then you can also use the or property, which is a little bit more relaxed property. So if I said or rectangles, all rectangles, and all geometry of red color, then I can say or. So it'll pick up all the rectangles as well as everything that's in red, whether it's rectangles or not. So that's a little more, more of a bigger set when you use or, but most typically you would use and, which is basically, it satisfies all of these requirements, which is, it has to be a rectangle as well as a red rectangle. So that's what I've done. And then this is, we've added this bounding box diagonal length filter as well. This is useful to eliminate long, skinny rectangles. We used to have only 2021, we only had the bounding box. But in some cases, long, skinny rectangles were being picked up for machining, and users wanted to eliminate that. And the way to control that would be to use the diagonal length. So that's the way we set it up. And the same thing, selection rules. Here for hole pocketing, I'm selecting all circles. And then I'm profiling. I'm selecting all rectangles, but no color filters here. So, and then I'm using the layers. I'm selecting all rectangles, but that use the default layer. So which is basically, it picks up all the outer ones. So this is how you set up rules. And the other thing you can see is you can load a completely different type of part here, as long as the geometry is set up similar. So let me, this one, load a part like this. It's completely different, and as far as the shape is concerned, but whatever program that I use to generate it, I'm following a certain set of rules. So saying all internal pockets are red rectangles, and then I have hole pockets that are circular, and then outer boundaries that are rectangular. So now I can do the same thing that I did in the previous file. I can load my knowledge base. So widget with rules, and then I'd say they automatically picked up the control geometry. Then I'm doing the red rectangles first, doing the pocketing, the whole pocketing, and then finally the outer periphery. So this is how we can set up knowledge bases with the enhanced rules in 2022, and it's quite powerful. And I should add the SDK. There's a lot of improvements in the SDK as well. For those of you not familiar with the SDK, it stands for the Software Development Kit that we ship with RhinoCAM. And we've added this function of loading knowledge bases in the SDK as well. We've enhanced that also. So for those of you who know Python programming and who are inclined, we have some customers with large installations who are using the SDK with the knowledge bases to automate their machining very, very efficiently. So again, if you're interested in that, you can talk to us about it. You would need some programming resources on your end to pull that off, but we can do what we can to help you out there. So, okay, let's move on. We got a few other things to catch up on. I think I'm running a little bit late. Let's talk about turning improvements. A couple of changes of note. One of the things we've done is we've added a global tolerance. So if you go to machining, we've added default tolerance for part mobs. This allows the control of tolerances for generating part geometry in turning. And this was sometimes a problem previously. This control helps us define the parts in a better way. And then one other change we've done is for parting off. Now the parting off operation honors the program point of the parting off tool. So that's a change as well that some of you have requested. Okay, let's talk about nesting now. Nesting also has seen some changes, some pretty good changes. We've added remnants. For those of you who are not familiar with the remnants, remnants are basically the leftover pieces of sheets that were not nested with parts. So we can now determine those remnants. So I'm going to I'll show you an example of that. I'm going to show you a simple example of how this works. Okay, this is back to nesting here. Okay, let's say we have this file, true shape nesting. I'm selecting true shape nesting. I'm going to select my sheet. Let's say I want a simple case. I'm just using one sheet of that selected parts. I've actually selected these parts. I've selected 5 of this part, and then 7 of these parts with the internal holes in them. And also in the options now, we can specify remnants, whether you want to generate remnants or not, which I've done already. And then I can say, I'll leave all of these default parameters, and I'll say execute nest. Now that's the nest that was done. And as you can see, that's the sheet. And then now we have a list of remnants. So the green portion that you see is basically the remnant of the sheet. And this can be output separately and can be used in subsequent nestings as sheets. So this is something that's pretty important, especially when you have multiple sheets and you have sheets that are not underutilized and you want to reuse them in different nesting scenarios later on down the road. So this is an important enhancement as well. So, oh, sorry, that's the help file. That's also something new that we've been added. Okay, that's a quick look at the nesting. Let's talk about post-processor enhancements. There's quite a few post-processor enhancements that have gone in. Let me bring up the what's new file. Any questions there, Don? Okay, this is the what's new document that I was talking about. And as you can see, there's quite a lot of other enhancement that you can, I did not touch upon, but you can read through quickly through the post-processor enhancements. We've added separate G codes for turning off coolant. This is something, again, requested by people. And then we've also added air coolant, as a separate option where you can turn off air coolant and the codes for the air coolant. In terms of the post-processor, the Python programmable post-processor, which is the new one, we've added a few methods to make it a little bit more powerful. And I'm very happy to say the Python programmable post is very flexible. There are lots of really nice things we're able to do with it. But it's a little bit complex in terms of from a user's perspective. In terms of setting it up. For using it, obviously, is quite easy, but for setting up the post-processors, it can be complex, but it can do a lot of neat things. We've added register number decrement for work offsets. New variables have been set up, setup name, and also multiple lines for linear motions and cut and rapid for G0s. Before we were restricted to a single line of code. Now a G0 motion can be any number of lines. You can have any number of macros for that. Post file extensions can be selected from the SPM file directly. And then work zero offset also was ability to, and then new options, post-processor string, and then also a cycle Z value variable has been added. So quite a few changes in the post as well. And then in terms of the software development kit, which I said, the ability to load knowledge bases has been added. So again, this makes it very powerful. So you can load knowledge bases for machining. And then also ability to select post processors. You can actually select posts and use different posts in machining different operations, if you will, or different part files, because you might have multiple machines and you might want to run different programs for different machines. So in that case, if you want to choose a different post, you would run a different program, if you will, using the SDK that you may either prompt the user for the post processor required, or hard code it in your posts in your SDK program. Again, a lot of nice changes. New examples have been added, and customers are using it right now, so which is nice. So we talked about that. Licensing. Let's talk about licensing, which is a big change is coming down the pike. Actually, good changes. We've added new modes for licensing, and we also changed the licensing, the way the licensing dialog looks. So I'll show you this. This is the new licensing. We've added right now, so we have 4 different types of licensing models. One is we have a node lock license, which is traditionally once you get the license, it's locked to a node, and then you'll have to manually release that in the license if you want to use it in another system, which is what we've been for the majority of cases we've been using. And then there's some problems with that, because if you get locked out, let's say you forgot to release it, you got it locked out, then you're basically stuck. So we've introduced this new cloud licensing model, where you basically, when you acquire the license, you get it for a certain lease time. We've set that lease time to be about 8 hours. So let's say you come in the morning and you're working, and you acquire that license, and then you go home after work, and then it automatically, the lease expires, which means it becomes available for use elsewhere. You could be on a plane somewhere, or you could be on vacation, and you can just fire up your laptop and that license will be available for you. Again, same thing in case you have a machine crash, and we don't have to get involved to release the license and all that rigmarole that we used to go through to figure out whether the license was locked up. We have to enable it and disable it, and there's quite a few things we had to do. All of that is eliminated if you had this cloud model, because after 8 hours, it becomes available to use elsewhere. So if you have a disk crash, fine, just get your new computer and that license is available for use. So I think this is going to be a very good change. The only downside to this is you have to have internet access when you first acquire the license. So at least once in 8 hours, you'll have to have internet access. So, and then the other 2 models are obviously the completely dark sites, which they don't have any internet access at all. In case of military establishments and highly secretive commercial enterprises, we offer this LAN daemon network, completely dark sites. And then, of course, for sites who need multiple network licenses, but they're still open to the internet, using port 80, we offer the network lock license. So these are the 4 license models. And when you buy the product or when you upgrade, we'll be able to help you with what's the right model for you. So that's basically a quick rundown of what's new in 2022. A lot of bug fixes as well. You can read about that in the What's New document that we will make available to all of you.
Also, Joe, there's no other major questions, but I want to make a couple of observations after watching this. I think users are really going to take advantage of the VisualCAD line widths. As you know, selecting geometry for various purposes can be a little bit difficult, because the line width is very thin.
Right, exactly, yeah.
You can use that line thickness and make those selections very easy. So that's one thing I noticed there. Also, on the now that we're posting the G code whenever we generate an operation, you can use that in combination with the suppressing rules, where like if you're working through a part and you're finalizing your operations, as you go down through the machining job, you can suppress those operations that you in your mind are complete and you don't want them overwritten when you regenerate.
Right.
And you can use that in combination. That would be a big time saver as well.
And also I think that's important because if let's say you have your part that you machine and you're very happy with it, you can basically freeze it. And so you come back after a year, you don't have to worry about regenerating anything. Everything's in there, even including the G code. So which is nice. You're right.
And there was other small, relatively unrelated questions. So we'll cover those and get answers back to you after the webinar.
All right. I mean, one other thing I should say is the most exciting part for me is probably not apparent in this demonstration, but it's the combination of the knowledge base rules that we are using and the SDK changes for RhinoCAM. This can be really a game changer for a lot of companies.
Also, sorry to interrupt.
You know that we have a few companies that we are already using this very productively. They've written their own almost a front end for machining and using RhinoCAM in the back end, and I can only see really big productivity enhancements using that. So I'm pretty excited about that one.
Okay, one other thing that I wanted to add also that I didn't mention a moment ago, AMS subscribers get the G code editor, and if you noticed, we integrated the G code editor into the milling module. So there's a lot of times users are they're concerned or they're worried about how the code is being formatted and whether that's causing a problem somewhere on the machine.
Right.
So I use the G code editor a lot, but now what you can do is you can automatically look at your G code and have it backplotted on your part in real time. So you can.
Don, we can't backplot it yet, not in this release. So it's only viewing of the G code. But if you have the G code editor module as part of the AMS, there you can backplot and on simulate as well. So that's why that's important to that's why we use that. In the AMS module. That's a much more complete module, but this integration right now is just the beginning. You'll see additional integrations down the road. Simulation will be one, display, and a lot of those things are down the road. So,
okay, that's it, Joe.
All right, thank you very much, everybody, for joining us, and drop us an email, questions if you have to support. If you have any sales related, send it to sales@mecsoft.com. I'll be more than happy to help you. Thank you very much.
Thank you,
Take
guys.
care.
Have a good day.